we go. I'm not going to take overly long to be able to teach you today. What we're going to be learning today is actually something that I think you guys are more than capable of doing. So yesterday we learned about foiling, right? Another term for foiling is, stay quiet for me. If we have 2x minus 1 and 3x plus 2, another term for foiling is double distribute. Okay? So if we ignore the foiling method, another term for this is called double distribute, and it's the exact same thing. We take 2x to both things, right? So it's like distribute, but you're doing it twice. So you go 2x times 3x, which is 6x squared, 2x times 2, which is 4x, right? So you take the first term and you distribute it twice. Yeah, but I'm teaching it a different way for what's coming next. And then you take the second term and you distribute it twice. So this is why it's called double distribute. And then, of course, you do the exact same thing you did as foiling. You combine like terms, and you have your answer. That's called double distribute. Or, it's the exact same thing as foiling, but another term for it is double distribute. Now, the reason why it's called double distribute is because you're distributing twice. You're taking the 2x through, and then you're taking the negative 1 through. So the reason why I like to show people that is for what we're going to learn today. So if we have a binomial times a trinomial. So if we have a binomial times a trinomial, we can't FOIL. Why can we not FOIL? Who could tell me why I can't FOIL that?
Because there's 3 on the one.
Yeah, because it's a trinomial, right? Foiling only works when it's a binomial times a binomial. So here we go. In this case right here, we have to use the double distribute method. So we're going to take this 2x and we're going to distribute it to the 3 terms inside of the trinomial. So 2x times 3x cubed is 6x cubed. Sorry, 2x times 3x squared is 6x cubed. 2x times 4x is 8x squared. I need to write bigger, I'm sorry. Here, I'm going to scroll that. 2x times negative 4 is negative 8x. So that's the first distribution, right? We distribute the first number to all 3 terms afterward. The second distribution is we're going to take the second term and distribute it to all 3 terms after it. Negative 9 times 3x squared is negative 27x squared. Negative 9 times 4x is negative 36x. And negative 9 times negative 4 is positive 36. So now we have this nasty formula. Kason, what do we do next? Okay, we got to combine together like terms. So we start off with the greatest exponent. Then we look for the next highest exponent, which is x squared. So 8x squared minus 27x squared is negative 19x squared. Negative 8x minus 36x is negative 44x. Then plus 36, and there's your solution. So I had a professor one time teach it like this. He said you're multiplying a monomial by a polynomial 2 times. So if we cover up the 9, we're multiplying 2x by that polynomial, and then we cover up the 2x, and we're multiplying the 9 times that polynomial. So let's do another. Here, we're going to make it look a little bit harder. So 4y squared minus 3 and 3y squared plus 7y minus 2. Okay, we're going to take the 4y squared, we're going to multiply it to the 3y squared, which gives us 12y squared. Am I right? Yes. Why is that wrong? Good. Thank you, somebody, for doing that. Why is it to the 4th? Thank you. You're adding the exponents, right? Okay. 4y squared to 7y gives us 28y cubed. You multiply the whole numbers, add the exponents, right? 4y squared times negative 2 is negative 8y squared. And then we did all the terms with the 4y squared, right? Now we're going to do all the terms with the negative 3. Negative 3 times 3y squared is negative 9y squared. Negative 3 times 7y is negative 21y. Negative 3 times negative 2 is a positive 6. What do we do next? Okay, do we have any like terms? Good, so the other things just become part of our answer. Combine together the y squareds, and everything else just becomes part of our answer. And there's your solution. So that's multiplying a binomial by a trinomial. It's called double distributing. Double distribute. You're distributing both numbers in the binomial to the trinomial. Any questions on that? Okay. The next thing we're going to do is I'm going to actually let you guys try to figure this one out on your own as long as you stay quiet before I teach it. I'm curious who can figure it out. So the next thing we're going to do is what's called multiplying a trinomial by a trinomial. I'm going to try to make it somewhat easy. Hold on. Okay, if you don't know, that's fine. Just sit there quietly, but there's a trinomial times a trinomial. I'm going to give you 2 minutes to try to figure this one out if you can. Think about what we've done and try to figure it out. Okay, you guys ready? So, who thinks they know how to do it? Derek? What do you think we're going to do? Okay, so let's take the 2n squared to all three numbers. That's going to give us 10n to the 4th minus 4n squared minus 16n, so 4n cubed, minus 16n squared. Okay, then what? The 3n to all three numbers, right? So we're going to get plus 15n cubed minus 6n squared minus 24n. Then the negative 6 to all three numbers. How important is it going to be to pay attention to signs? Yeah, very, very, very important. If you don't pay attention to signs here, it'll kill you. Okay, so we get this huge problem. So if the last one is called the double distribute, what would this one be called? Triple distribute. Okay? So you just take every single term inside of the trinomial and distribute it to the other trinomial 3 times. So we do it in, looks like we don't have another n to the 4th. We do have another n cubed, which is right here. So that gives us plus 11n cubed. We have a negative 16n squared, a negative 6n squared, and a negative 30n squared. Is that 52?
Yeah.
Negative 52n squared. And then we have a negative 24n and then 12n, which is negative 12n. And then a plus 48 on the end. And that's called the triple distribute, so nothing changes, right? The only difference is your problem is just going to continue to get bigger and bigger and bigger based on the number of times you're going to distribute. So, my question to you is this. Can you multiply any set of polynomials together? What do you guys think? Yeah. You can multiply a binomial times a 10th term polynomial. Right? The only difference is you just take each member of the left and multiply it to everything in the right one. So if you had a 10th term polynomial by a 10th term polynomial, it would be a 10 times distribute problem, which would fill up an entire piece of paper a couple times over, right? But luckily for us, this is the biggest you guys are going to get this year. Next year you'll go to a 4th term polynomial and then you learn how to factor it backwards. But as of this year, that's as big as we're going to get. Any questions on that? Okay, that's it. What?
Hey, what if my title is?
Title it multiplying polynomials. It's still kind of right there. Put it right